All right, we're going to continue our little journey through circles. And I just happen to have a circle right here. Isn't that nice?
You said it every time you insert something.
I like saying that. Are you supposed to keep it? What do you mean?
You never collected our homework.
Oh, yeah. Well, we'll collect it after I'm done here. I just forgot. I've started recording, so we'll just do this first. Okay, we talked about a bunch of things. We talked about chord. We talked about the radius and all that good stuff. What I'm going to do is I'm going to draw 2 radii in this circle. Doesn't that sound cool? Radii.
Yes. Radio.
We watched that
Oops.
movie in Bible.
All right, let's pay attention now. No more silly comments. Just keep the silliness to yourself, and let's concentrate on what we're doing here. Look, I drew 2 radii. Okay, they both, by definition, they have to hit the center of the circle. Would you agree? Hit the center of the circle, and then they hit a point on the circle. Center of the circle, point on the circle. Everybody got that? Let's label these. Let's call this A, call this B, and call this C. So what have I formed right here when I draw 2 radii? I formed, well, not really a triangle necessarily, but I did form a what?
A Pac-Man.
Come on.
A pie chart.
A what?
Triangle.
Pie chart. An arc.
Angle.
Thank you. Goodness gracious. Okay, it's an angle. All right. I didn't think it was that hard. I even put the little arc thing on here. Okay. This is an angle. All right. Where is the vertex of this angle located?
B.
Yeah, that's true. I probably didn't word it correctly, but generally at the what of the circle?
Center.
The center of the circle. Okay. So that's at the center of the circle, the vertex of that angle. Since it's at the center of the circle, we give this angle a name. We call it the central angle. All right. So that angle right there is called the central angle. Now that's pretty important to know. I mean, not necessarily the name of it, but there's going to be a relationship we're going to see here in just a second between the central angle and something else. But let me talk about something else first. Do you see from A to C? If I wanted to travel from A to C, I would go along the circle, wouldn't I? Is that a straight line along from A to C? No. It's around the circle. Okay? Let's just make it a little bit thicker. Watch, if I go from A to C, I'll try to trace this as best as I can. Ooh, that was pretty good. Look at that. Well, I got a little bit left over here, but that's okay. See that little chunk right there, that little piece of the pie? All right, just from A to C I'm talking, all right? From A to C, we call an arc. We've talked about that before. Remember how we put these little arc things in here? But this is truly an arc. Now, this is how we label an arc. An arc, actually, why did I put a B? I think because the last class I made that B right here. Let's make this one C. So here's what we do. We don't say the word arc, or we don't put the word arc in front of it. We have a symbol, just like we had symbols for many, many other things that we've done this year. There's a symbol for arc, and it looks like this. All right, just like a little arc over top of it. All right, it's pretty easy, isn't it? So that's arc AC. Now, what do we measure an angle with? If I was to measure this angle, yeah, I shouldn't say that. What are units of measure? Degrees, right. Our units of measure for an angle are in degrees. Well, same thing with the arc. The arc is also measured in degrees. For instance, I think you're already pretty familiar with some of that, especially when we did, remember we did that angle of elevation and all that kind of stuff, and we had the X and Y axis. Remember doing this? If we went to there, how many degrees was that? 90 degrees. If we went to here, it was what? It was 180 degrees. Follow me? 270, and then all the way around would be what? 360. Agreed? All right, so that's kind of the same thing. So watch, if I went from here to here, that's actually a degree measure, or it's a degree measure from here to here. What if I went exactly halfway around? How many degrees would that be? 180 degrees. What if I went all the way around? That would be 360, okay? But what if I just went a chunk? I don't know what that is. Let's just make up one. What do you think that angle is?
60.
It's probably a little more than 60.
65.
Yeah, it's probably around 60. Let's just make it easy and say 70, okay? Is that all right? Just make it easy for the sake of the math. So that arc, that angle right there is 70 degrees. Now, what did I say? We measure arcs in the same thing, don't we? We measure in degrees with an arc. So arc AC is also what? Well, actually, I shouldn't tell you don't know that because I got to tell you something first. Here's a theorem. I think it's a theorem. Or just, let me see if it's a theorem. I don't even know it's a theorem, but it's something that we know. All right, we'll put it that way. That the angle that's made right here of the central angle, this central angle is equal to the arc that it cuts off. Do you hear how I said that? The angle is equal to the arc that it cuts off. When I say it cuts off, see this angle comes here and it hits right here, doesn't it? And the angle comes right here and it hits right here. So it cuts off that arc right there. So this arc is equal to this angle. We measure them both in degrees, so that's easy. So if this is 70 degrees, what's the arc? That's 70 degrees. It couldn't be easier, could it? Okay, so the central arc is equal, the central angle is equal to the arc that it cuts off. Everybody hear me on that? That's easy, easy, easy stuff, isn't it? Yeah? All right, very good. So I could say that that's 70 degrees. Some people do this. Some people go like this and like this, right? Put a little thing right there. I don't know, you might see that sometimes. Or if you didn't even see the arrows, if those weren't even there, and if you just put a 70 between these two letters right there, that just indicates that arc is 70 degrees. So it kind of goes vice versa. If I said that this arc was 70 degrees, what do you think you could tell me about the central angle? That the central angle is 70 degrees. All right, it goes both ways. I think you kind of figured that out yourself anyway. We okay with that? All right, that's the easy part. It's not always quite that easy, but let's do this. Tell you what, let's start from scratch so we don't have to erase all that. All right, let me do a quick little example here. Let me show you something. If I had this, let's see, it's about right there, and this is about right there. That's close enough. No, it's not. Let's put it so it hits. There we go. All right, this right here is a right angle. So they tell you this. They also tell you that this is 130 degrees, that big arc or that angle right there, and they're asking to solve for x. Put a little degree symbol. This is really not that hard because look, if I went from here all the way around to where I started again, how many degrees would that be? 360. So what about the arcs or the angles inside of here? I keep getting mixed up. The angles are going to be what? They're going to add up to be 360. Exactly. All right. So this is already 90. This is 130. What math do we do to solve for x? Yeah. Now somebody in the last class said that. I would do it like this in the calculator. I wouldn't say plus 90 because I know what you're saying. You're saying minus parentheses 130 plus 90. I get that. But in a calculator, I would just do this, wouldn't you? I would just take them away from 360. So let's move that over here. So 360 minus 130 minus 90, and that's 140. Okay, so it's 140. So what's this angle right here? It's 140 degrees. All right. That's an example they have in the book. That's pretty simple. Would you agree? All right. They're just showing you that all the interior angles right here, all these central angles, will all add up to 360. Why? Because they cut off arcs that make up a whole entire circle. The whole entire circle is 360, so they have to be 360. Okay, that was pretty simple. Let's talk more about some arcs now. Actually, let's get rid of the numbers. I'll keep those arcs where they are. And let's label them. And we're not going to put some numbers in here. We're just going to talk again more about how to label stuff. And let's just call this A. Call this B. Call this C. And I'm going to do one more thing here. Let's take this one. Let's take this one. I'm going to extend it all the way to the other side of the circle right there. So what did I just draw right there? What is that thing now? It's a diameter. So CD. All right, there we go. Now let me talk about this. We talked about how to label an arc, right? I want to talk specifically about some of these arcs. Now this is that's 90 degrees, isn't it? Okay. And it doesn't even matter if it's 90. I don't really care. I'm going to actually get rid of that. So if I went from A to B, what would I call that arc right there? From here, and I went in this direction to here. Okay, what would I call that arc? Arc AB. All right, we talked about that earlier. But what if I did this? Now watch carefully. You watching? Everybody watching, right? Chris? What if I started at A and I went to B the other way? What if I went all the way around this way? Could I call that arc AB? So how do I know which arc I'm talking about? Am I talking about this little arc right here, or am I talking about this big arc all the way around? How do I know?
Because you know which way the
You know
thing
your
above
starting
the
point
AB,
and your
you
stopping.
see the picture.
Nah, I don't. You can't just look. You can't really just look at it and see. What if I wanted to talk about this arc from A this direction to
You have to
B?
include another point.
Exactly. You got to include another point. Okay. So if I go a short direction, which means, listen to me, less than 180 degrees. If my arc is less than 180 degrees, and from A to B is, isn't it? All right, because 180 would be like way out here, wouldn't it? So B is definitely, from A to B, is definitely less than 180 degrees. I can just use two letters like this. We call this a minor arc. A minor arc is less than, what did I say? Than 180 degrees. Okay, so a minor, I should put the word arc in there. Arc. I have it all in there? Okay. A minor arc is less than 180 degrees. You all right with that? So I could call that AB. But what if I wanted to go the other way and go from A through D through C up to B that way? What would I call that?
Say arc ACB. ACB, sorry.
Yeah, you could say ACB. So a minor arc, you use 2 points. Do you see that? What's an arc that would be more than 180? What do you think you would call that? Yeah, let's write that down before I put the arc stuff. So a major arc is what? Not less than, but greater than 180 degrees.
And then an arc that's 180 degrees would be a semi.
Exactly right. We'll get to that in just a second as soon as we do this. All right? So let's talk about the major arc. So the major arc, look, if I went from A and I went this direction, that would be a major arc, wouldn't it? Because it's greater than 180 degrees. It's more than half a circle. So that's a major arc. How do we name that? Well, you got to have your endpoints. So my endpoints are A and B, correct? But if I go major, I got to put 1 point. Not at least, but exactly 1 point in between. It doesn't have to be like the middle point or anything like that. I could have 4 or 5 or 6 different points here. I just pick one of them. So somebody said, I think it was Taylor said, let's call it ACB.
That's me.
Oh, that was Alyssa, sorry. Got to give you credit. All right, so I could call that arc ACB. You see it? I'm not going to draw all the arcs in here because it gets a little confusing if I do. But if I start at A and I go all the way around this way to B, I could call this arc ACB. Or I could call it something else. That's not the only thing I could call it. If I started at A, what else could I call it? ADB. Right, I could call it ADB if I wanted to. What does that mean? It means you start at A, you go through point D, right? And you end up where? At point B. So a major arc has 3 points. Minor arc has how many? 2 under that arc. Everybody got that straight?
Yes.
All right. I think that's pretty important stuff for what we're going to do later on in this chapter. And who said it? Okay. So Alex said, what if we go from, watch this, what if we go from D to B? Could I just call that arc DB? If I just called it arc DB, how do I know if I go this way or this way? Well, yeah, but it's not the same arc, though. It's the same number of degrees. It's the same measure, but it's a completely different arc, right? Look, if you walk this way, you're seeing different sights, aren't you, than what you're seeing over here? All right, so it's a different path. It's a completely different path. It's the same number of degrees, I agree with you, but it's a different arc. So how do I differentiate between this arc going above or this arc going below? Well, stick another point in there, right? And we call that a semicircle. All right, so a semicircle is equal to, it's an arc, okay, it's still an arc, but it's equal to 180 degrees. So I don't just call it DB because I don't know which way I go. Do I go through A to get to B, or do I go through C to get to B? I really don't know. So I got to have a third point. So on a semicircle, you label that with 3 points as well. So let's, what do you want to call it? D what?
Yeah.
AB. All right. So you could call it that, or what else could you call it? DCB. You could always go backwards too, couldn't you? You could go BAD,
Bad.
that bad angle or that bad arc, or you could go BCD. It doesn't matter. It doesn't matter. You don't have to start at D and end at B. You could start at B and end at D, but you got to have a point in the middle. What if I had half a dozen points in here? Do I put all those points? No, I just pick one of them. I only use my 2 endpoints and I pick one that's in between. It doesn't matter which one you pick. All right. This was the only one that was labeled at the time, so I picked that one. Make sense? All right. So DAB would be this top arc right here. What if I wanted to go the other way? What would I name that arc? I won't write that down. D what? If I wanted to go this way, what would I name that semicircle, that arc? DCB. Or I could say what? BCD. Doesn't matter. Even though you're still going 180 degrees, they're two completely different arcs though, aren't they? We good? Okay. So that kind of makes sense, I hope. Let's see what else I want to do. Tell you what, let's do this. I didn't do this in the last class. I just noticed this. Are you watching? What if I did this and I did this? 2 diameters, right? Because they all go through, both of them go through the center. All right. Let's label some stuff: A, B, C, and D. All right. Without putting any numbers in there whatsoever, I can tell something about arc AD and arc BC. Why are the 2 arcs equal to each other?
Because they have the same angle.
Because look at the central angles. The central angles are equal to each other, agreed? Okay, so if the 2 central angles are the same, what's true about the arcs?
They're also
Okay, they're the same as well. This arc is equal to this angle, and this arc up here is equal to this angle. If the 2 angles are equal, guess what's true about the 2 arcs? This arc and this arc are equal to each other as well. Yep, you could say that AB, arc AB is equal to arc DC, couldn't you? Because you've got these 2 angles equal to each other. So that's something to look out for, right? You might see that show up somewhere. That's not too hard to figure out, but it's something that we need to say. Okay, now we're finally getting somewhere. I think I can skip that. Let's do this. Let's talk about the length of the arc. We just finished talking about circumference, didn't we? From last night's homework? Yes? Okay. So what we're going to do here is we're going to find the length around part of the circle. Okay, the distance. I'm just going to make this angle right here, and we'll call this AB for lack of imagination. And we'll call this center C. All right, everybody good so far? All right. What are we trying to do? We're trying to find, and let's change colors. We're trying to find the distance from A to B around the circle, though. Okay. Everybody understand that? We're not going straight line distance from A to B. We're going around the circle. How far is it? If you're going to walk around this circle and you're going to start at point A, end up at point B, you want to find out how far you've walked. Let's put a radius in here. Let's say the radius of the circle is 5. Just make that up, okay? And I want to find that distance from A to B around the circle. Well, let me ask you this before we get to this actual distance right there. What is the distance around the whole entire circle? Give me a formula for it. It's the circumference, right? If I find the distance around the whole circle, it's the circumference. The circumference is equal to what? 2 pi r. That would be the whole entire circle. How many degrees in the whole entire circle? 360, right? So if I go around all 360, it would be what? 2 pi r. But am I going all the way around from B to A or A to B? Am I going around the whole entire circle? No, I'm only going around a portion of it. And let's just say it's 60 degrees, just make it easy, okay? Everybody with me? So it's 60 degrees, and the radius is 5. So this is how we find the length of this little arc. Okay, so we'll say this. We'll say the arc length. There's no real symbol for that. So we'll say the arc length is equal to what? Now, it's not 2 pi r, because 2 pi r is the distance around the whole circle. We're only doing a little chunk of the circle, a little piece of the circle. Piece of pi, right? We're only doing a little piece of this. How much of the whole circle? Listen to what I said. How much out of the whole entire circle are we doing? We're going from here to here. Well, but talk numbers here. Well, it's not 60%, because 60% would mean 60 out of 100. This is not 60 out of 100. This is 60 out of what? 360. There's 360 altogether, okay? So this is, you're going 60 out of, what is out of in math? Divide by, right? 60 out of 360, all right? But then what? Is that my answer? Is that how long that is? Just 60 out of 360? No. What is it? 2 what? Pi r. Remember, 2 pi r is the whole thing. 60 out of 360 tells me how much of the whole thing. Well, what's 60 over 360? It's like 1/6, isn't it? So really, what am I doing? I'm only going 1/6 of the entire circle. Do you see that? This right here is 1/6. This right here is the entire circle. So this length is 1/6 of the entire circle. Yes, no, what?
Yes.
Okay. Hopefully this is not falling on deaf ears. All right. So and that's how you work the thing out. So let's punch some stuff in a calculator, see what we get. So let's find the length of that. Let's clear that. Let's go 60 out of 360. We'll just put all the numbers in. 60 divided by 360 equals that. Times what? 2 times pi, right? I'll just use the pi button. Okay, times what? 5. Or you could have just said pi times 10, couldn't you?
5.
All right, and then equals, boom, there it is. 5 point, let's say 2, 5.2. So that means that this distance right here is 5.2. Does that make any sense? Why it would be 5.2? Yeah, because we're going, it's going to be longer. Well, I'm not even going to worry about that. It's 5.2, all right? So from here to here is exactly 5.2. What do you think of that? It's not so hard, is it?
No.
So what if you had some crazy angle in here? I don't know how crazy that would be, but 72. All right, let's say that that's 72 degrees. And I said, what is the length? What is the arc length of BA? What would you do? You'd go 72 over 360 times 2 pi r, right? In this case, what is r? R is 5, isn't it? So let's see what that would be. Do you think that would be longer or smaller than when it was 60 degrees? It's going to be longer, right? Because we're going more around the circle, right? We're going further around the circle, so it's going to be further distance. So let's see what we get. 72 divided by 360. Oops. Yeah, let's try it again. 72 divided by 360. There we go. All right, it's 0.2 times what? Times 2 times pi times 5. And then there it is. It's about 6.3, right? So at 72, the arc length is equal to around 6.3. That's longer than what the 5.2 was, isn't it? All right, and it should be. Further you go around the circle, the longer, right? The longer you went. Make sense?
Yes.
That's not so hard, is it?
No.
No. I think that's where they end. Let me see if I missed anything that I really need to talk about. No, that's fine. I don't need to do that. Arc length. Yeah, I think that's it. Let me give you a few problems to work on. Oh, by the way, listen to me. Are you everybody listening? This is very important. We don't have class tomorrow because it's half day and you're just doing morning classes, okay? But listen, that doesn't mean you're not going to be learning anything. I hate to do this, but I don't really hate it that much, but but I'm doing it anyway. So listen, it's your responsibility. This is not just a, hey, if you get a chance, do this. No, I'm telling you to do this. Okay, this is your assignment for tomorrow. You are to watch the YouTube video. I'll be teaching first period tomorrow. Okay, so I'll put the first period class on your YouTube page, right, on 7th. If it's not on there, look at first period. It's probably on there. Okay, but I'll try to put it on yours as well. So watch the lesson. I'll give you the homework, so just like you were here. So sorry, it's a half day and all that, but it's still school. All right, we got to keep moving. Just because we're missing one class doesn't mean we're just going to blow off a whole day. All right, so it's going to be your responsibility to watch the YouTube video and get the homework done. So on Monday, what I assign tomorrow will be due on Monday. You understand?
Yes.
Okay. Well, what I assign today will also be due on Monday because you won't be here tomorrow to turn it in. All right, so let me give you the problems. So make sure that you do that, please. It's very important.
My circles are good. They are like so not right.
So here we go. It's section. Are you going to write this down? It's section 10-2. It's pages 696, 697. And we're doing 12 to 23. And we're also doing 26 to 41. All right? 12 to 23, 26 to 41. Yeah, just put your homework on the up front, and then I'll take them.